Hi class. Today we come to section 3.2, logarithmic functions. Okay, so in the last class we talked about exponential functions. We really apply to to estimate the amount of populations or amounts of money or something in like amount of values in the future. Okay. And keep in mind that we try to estimate that value by the form of the exponential function. However, there's some case that instead of asking you about the value of the future, I'm gonna ask you about like how many years, how many hours, or basically like the time that's amount. So log function is gonna be the one help you on that, okay? But log function also is an inverse function, exponential function. Okay. So what does that mean? Let's we take a look at example 3.4. Yeah. So a population of 50 flies is expected to double every week, leading out leading at a population growth function. I will change this to be like followed by a population growth functions. Okay. So f of x equals to 50 times 2 raised to x. Okay, so what is this? This is a exponential function, right? It is an exponential function. Go, because we have b is greater than 1 in this case. B equals 2 is greater than 1 in this case. Okay. And in here we have x present for the number of weeks that have passed since the initial population was observed. So use a color here. Okay. So the question in here is asking us is when. So keep in mind the word when, right? When is going to be find us. Right? So like I say, log function answer you the question when. Okay. So let's we try to have some guessing on for this. Okay, so if I have 500, if I have say I have Lx equal to 500, right? So we can have set up a function as 500 divided by Oh, sorry. My server pen is kept like crazy today. So I have 500. Give me 1 second. Fix myself. Okay, so then we can set up function as 500 equal to 50 times 2 raised to x. Right. So at first, I'm trying to figure out what is x in here gonna be, right? Trying to have what is x in here gonna be. The problem in here is x is on the exponent. Okay, so what about I'm gonna try to, try to isolate the term that have x on the exponent. So I would like to divide both sides by 50, right? Because I want the 2 raised to x there to be isolated. And then I have the left hand side gonna be 10. The right hand side gonna be just 2 raised to x. Okay. Now, how can I solve this one? Okay, keep in mind that my question right now is, what is power up to get to get 10, right? What is power up to get 10, right? Similar, like if I say like 2 to the, oh my serpent's kind of crazy today. 2 question marks, or maybe using the box, maybe 2 raised to somethings will be equal to 10. Right? What is that things? So if you guess that, let's say if 2, maybe I'm using typing. We know that 2 raised to 3 equal to 8, right? And we know that. And 2 raised to 4 equal to 16. Oh, so that means that my power there supposed to be like in between 3 and 4, right? Okay, so x must be a number in between 3 and 4. So that's all I can guess, but how can we have a like an accurate answer for this case? Right. Right. So we must use log function to help us. Okay. So now let's learn about log. So none of the function we have discussed will work because why? We learned about linear function, right? It's just a line, and the x is not in the exponent. Quadratic functions is a parabola as form as x squared plus 2x. I mean, x squared plus ax squared plus bx plus c, and also x is not in the exponent, right? Exponential function, yes, it's on the exponent, but can you solve it? No, there is nothing, no rule that help you to solve it, right? So we need to introduce new function, and we call that is log, and something that unders the exponential function. Okay, and since exponential function have different base, we will define the corresponding log of different base as well. So let's get some definitions. The law of logarithms with base b's, okay, can be written as log baby. You see the babies there? Is going to be under the exponential function b raised to x. All right. So we can also name b now, instead of grow factor like in exponential function before, we can also name as base b. Okay. Okay. So now we have the statement b raised to x equal to c is the same as log baby of c equal to the x. So think about when you have exponential function, I mean exponential form as b raised to x equals c there is, and you want to find for x, right? So it's same as what is the power of b to get c? It's the same meaning in that. And the log function, or the log, let's say logarithmic logarithms, is answer for that, because you are looking for x here, right? Log here, logs baby of c is exactly meaning that it is the power of b to get c. Okay, this is logs baby of c. Maybe I'm gonna write it for this case. It is gonna be logs baby of c. All right. What is the power of b to get c? This is the power will be equal to logs baby of c. Does that make sense? Okay, so let's have some spectral notation, but actually I'm gonna talk about that later. I would like to have some example here, and I want to write the exponential function, I mean exponential equation 4 squared equal to 16 as an equivalent log equation. So And you see in here, I have power, let's say, note 10. Power is 2. Base is 4, right? So the question is, when you're trying to convert it to be the log, right? Keep in mind that log is a power. Log is power, right? So then the power must be moved to the other side. So you will say logs base b or logs base 4 of 16, right? So logs base 4 of 16 equal to the 2, right? And in the word, I mean, in the meaning of that, it's gonna say like the power of 4 to get 16 is 2. Okay. Right. Move this a little bit out here. So similarly, you can go ahead and try to rewrite the one below here. Okay, you can go ahead and pause my videos and try it. Okay, I can do one more for you to make sure. So you can start with log, right? Base is 3 of 81 equal to 4, right? Of 81 equal to 4, right? Keep in mind that's the whole log will be the power, right? The power must be the other hand side. Yeah. Okay, now try in 1 minute and then get back to me and see, compare the answer. Okay. Okay, so this is the answer. Go ahead and try to compare. So make sure that all the power is in the other hand side of the log form, right? So just keep in mind that the last one is logs base e, and I will have another notation for it, but you should have the answer as log base e of 1 equal to 0. Okay. So now let's move up back. Okay. So as you remember that we have in, for example, in square root or in root, let's say root 3, right? Let's say root 3 is radical with the index 3 of x, right? But root 2 we also call as square root, can be just right as the radical with no index. So that means that there's a case that we have hidden index, right? For the for that. Okay. In log function, in log form, we also have the case that base become hidden, and that's going to be very common log, and we call logs base 10. So keep in mind that log base 10 will be written at log of x. So if you see in the calculators with the notation as logs, That means logs by 10. Let me open the TI for you guys to see. Oh. Let me see. Okay, so as you see, if you have TI 83, right? Okay, you should have something like log and LN here, right? Log is log base 10. Okay, you don't have in calculator, you don't have log base 2, you don't have log base 3, you just have log base 10. Okay, so this is the same meanings as what is power of 10 to raise to x, something like that, right? So now we have logs by e. Okay, let's use other colors. Can be rewrite or can be written as ln of x. Okay, and we also call it natural log. Okay. And log base 10 can be can be called common log. All right. So there are two logs that can be have a structural notation. Okay. We have two handy properties that you may really need it to make the work less. Okay, so first one gonna be logs base b of b raised to x, gonna be equal to x, and you see that we have in here base b and the argument are the same. Argument b are the same. The only things that's gonna be gonna be the power of that argument. Okay, so as you see right now, the power is x. All right, so you may try to decode this log. I'm gonna say like, what is the power of b to raise to b raised to x? So that's just x only, right? Okay, so the next case is an inverse of that. We have base b raised to power logs by b of x. Will also just be the x. And at least see right now we have exponential form, and the exponent now is a log form with the base of that log is equal to the base of the exponential form. So you left out with just the argument, which is x. So keep in mind these two handy properties. We're gonna use that a lot to make it quicker for solving exponential function or log function. Okay, we move down. Come back to the exercise 3.7. Now I can change this to be the form as natural logs of 1, right? We don't have base e. I mean, we have hidden base e there, right? We don't have to rewrite the base e. We should write as natural log of 1, okay? Because natural log meaning is log by e. Okay, so now we're gonna try to evaluate logs of 10,000. No, I mean, sorry, 1 millions, right? How to evaluate that? So keep in mind that this is the same as logs by 10 of 1,000, 1 millions, right? So keep in mind, like it is the same meaning as what is power of 10? What is the power of base 10 to get 1 millions, right? It is a sidewalk. I'm gonna make a box. So I would like to apply the one of the handy probability here. I try to make my argument to be in the form with the same base at 10, and I'm gonna left out just the power, so I can rewrite it as logs by 10 of 10 raised to power 1, 2, 3, 4, 5, 6. And that means I left out, which is 6. And then you see in here, it actually, I mean, if you think about the way you convert this to be 10 to 6, we also have the question mark will be 6 only, right? Because you have the same base right now, just the power are going to be the same. Okay. What about log base 25 equal to 5? So I will make, let's say I make a box in here, okay, and I convert it into the exponential form. I say, oh, 25 raised to box will be equal to 5. How can I do that? Oh, we know that the square root of 25 will be equal to 5, right? So keep in mind that 25, square root 25 can be rewritten as 25 raised to power 1/2, and that's equal to 5. So I would like to say the box must be 1/2 only. Does that make sense? And that means let me color here. That means I'm gonna say logs of base 25 of 5 will be equal to 1/2 only. And this is gonna be the answer for this part B. We don't really gonna have some problem like this in our business class for like logs by of 25 raised to 5, okay? But anyway, I want to introduce about the case that you have the base is like a bigger than the argument things. Okay, so that is for example 3.6. We did apply the first handy properties, right? For the second one, let's say, for example, if I have four, example here, 4 raised to log base 4 of x. I can say it's equal to x only. That's all. And for example, of logs baby, I'm gonna say log base 3 of 3 raised to x will be just equal to x. Okay, so let's we move down and try to evaluate the log below. Okay, so go ahead and try in about like 5 minutes, and then plays the videos to see the answer, right? Okay, so this is the answer. The first two is well, the first two is 3 and 2. By I do by the way that I apply the handy property, the first handy property. I just change the argument 64 change to be 4 raised to 3, so I can end up with only 3, right? Similar with B, I change 2 1 2. I mean 1 2 1 becomes 11 raised to power 2, and that's make me the power is 2. The third case, you can also apply handy property, but maybe if you couldn't figure out like how can you make this one number one here change to be 3 to power something, maybe you can write like 3 to power question mark equal to 1, and then you know that 3 to power 0 will be equal to 1, and that's end up with question mark will be equal to 0, which means the log base 3 of 1 will be equal to 0. And I would like to give you like one more special property that logs base anything maybe of 1 will always give you a 0 special property. Okay. So if you see again the argument equal to 1, whatever base is going to be, it's always going to give you equal to 0, right? Okay, so for the last case, which is I'm gonna say this is a challenge one, right? You have to remember that I can convert from 1/32 to be 1/2 to the power 5, because we know that 2 to the power 5 is 32. However, what about how can I make this 1/1 divided by 2 raised to the power 5 will be equal to 2 raised to -5. Keep in mind that we are having the rule as in exponentials, 1 was let me go up here a little bit. Okay, I actually believe that this may be not, it should stay here, that's okay. For example, that we have 2 to raised power -3 will be always equal to 1/2 raised to power 3. In conversely, 1 raised to power 2 to power 3 will be 2 raised to power -3. All right, this one I am like this one. So, or I would say like 2 to power 2 to power negative n can be rewritten as 1/2 raised to n. So that is a rule for applying in this case, okay? And you end up with answer at 95 for power in this case. And that means what? That means you will never end up with the log I mean you will never end up with the base and argument less than 0. I mean you will never have argument less than 0. Okay, 1/2 will never less than 0. Okay, so let's moving down and we talk about the graph of log function. So let's create, let's see, let's compare the exponential and the log function by computing few values and graphing. So let's start with x equal to -2. I will have the exponential function is 2 raised to -2 equal to 1/4, right? 2 raised to 2. That's maybe I'm gonna slow down, say 2 to the power 2 and 1/4. And then for the next k, I'm gonna end up with 0. And then 2 to the power 0 is 1. And the next k I have like 2. I have 2 raised to 2 will make 4. So that means what? If I have -2 here, I will have 1/4, which is really close to 0. I have 0 will make 1. I have 2 will make 4. So let's connect those together. All right. And keep in mind that the graph of exponential function is will never go down to negative, or I mean even like it just go along with the axis. Okay, so now in the other hand side, we'll use a blue one. Okay, and we have logs by 2 of x. Okay, since this is the inverse of each other, I will say I'm gonna use x. In this case, I don't want to use negative. Okay, I'm gonna use the 1/4. I'm gonna use the value of y of fx in the exponential function. So I'm gonna use 1/4. And logs by 2 of 1, 4 will be equal to -2. Okay. So you can remember that's from exponential function in here, right? You see that 2 raised to -2 will be equal to 1, 4. So log base 2 of 1, 4 would mean like, what is power of 2 to make 1, 4, right? So that's the power of must be -2, right? So I put 1 in here, and I have loss by 2 of 1. What is that equal to? 0, right? What is the power of 2 to get number 1, right? So raise to number 1, that's 0. Okay, so what are number 2 here? Logs, sorry, not number 2, it's 4. Logs by 2 of 4 will be equal to 2, right? So inversely, right, I have x equal 1, 4 going to be here, and -2 will be here. 1, 0, so there's going to be another point, and I have 4 and 2, 4 and 2. So I will connect those together. And keep my dots. We don't want to have x value less than 0 or even equal to 0. So it should go along with the y-axis. And that means what? That means you will have the graph of log function is the inverse of fx function, or fx function will be inverse of log. And is on the graph, it reflects each other by y equal to x. Reflects by y equal to x. Okay, so f of x and g of x are inverse of each other. Okay. They have some common feature to the graph of logs. Okay. So first, the x-intercept of log function must be 1, 0. Yeah, it's always go through the x-intercept as 1, 0. And for x equals 0, it will be the x-intercept, because the x equals 0, that's going to be the vertical asymptote, because we don't have y-intercept, and because the graph just try to go along with it. And domain will be, and you see that the x will always just horizontally just go from 0 to positive infinity, not include 0, right? So that's the reason why you have x greater than 0, or from 0 to positive infinity not includes over here. For the range, it's going to be all real numbers, because you see the vertical one, right? It just go all the way down to -infinity, and go up to positive infinity slowly. Okay, but still, it's gonna be all real number. Okay, down here, I would like to introduce you some properties of log. We have exponent property. This exponent properties is important because it can help you to move down the power to the front of the log. And that's give us an idea to solving exponential function by this rule. We can use this prop to solve exponential equation. Yeah. Another rule that you may need is chain of the base. So, for example, log base b of a will be equal to log base c. So let me add the color here. Maybe a, right? So we're gonna have log base c of a divided by log base c of b. So what is this we can apply? For example, if you have log base 3 of 5, right? How can you handle this on calculators? There's no way if you cannot change it to be log base 10 of 5 over log base 10 of 3, right? So now you can open the calculators and just use log base 5 divided by log base 3 to get the answer. So this rule, this prop can help you to use calculator. Right? Okay, some other property of logs that we also needed. Such as sum of logs, if you have all, like you have like some addition between some log with same base b. Keep in mind that we have same base in this case, okay? Same base b in both of these cases. You will have logs base, you will combine that together and makes logs base b of a times c. So as you see right now, so you have addition between two logs that have two different arguments. So you combine that together with the same base of log, but the argument become a product between a and c. Right? And the difference of logs will be the subtraction between two log, and you keep in mind that you still have the same base, but now instead of getting products between A and C, keep in mind that you will have a fraction form between A over C, as A over C, and the log have negative in front of it will have the argument at the bottom is C now. Does that understand? So as you see, we have negative logs maybe of C, make C at the bottom. Okay. If you think about what is corresponding probability of exponent, is going to be the right hand side here. For example, like base B raised to A plus C can be rewrite as base B times raised to A times base B raised to C, and so on with B raised to A minus C as B raised to A divided by B raised to C. So there is very common mistake that students come up with logs by 10 or logs base B of A plus B will equal to log by A plus B. Okay, this is wrong statement because as you see that we should have logs by A at logs by not base B of A times B can be write as logs by A plus log base B. Okay, that should be okay if you write like that. Okay, because we do like extending, not combining. Yeah. Now let's think about how can I apply those property here in mathematics. So I'm gonna move down. Okay, now I have example 3.7. Want to solve this is exponential equation, right? So can you solve x right now? I know that 2 raised to 3 equal 8, but 2 raised to x, I mean 2 raised to something equal 10 could be a challenge, right? So what I'm gonna do is in this case there's no way if you try to guessing like that. Guessings. Right? We need to take log base 10, both sides. Yeah. So what I do, let me show you. I have logs by 10 of 2 raised to x equal to logs by 10 of 10. All right. So as you see now, I make the parentheses to make sure, right? Okay, and you see now, I am having, I put the log both sides. Don't gonna say like multiply by log both sides. This is wrong statement. Okay, you say like take logs both sides. Okay, because that means you convert you actually right now in the left hand side say, what is the power of 10 to get 2 raised to x? Okay, that's right. Okay, so we're gonna apply the first property, or we call it exponent property here. All right, and we can move the power down. Oh, this is cool property because why? We can move this power down to the front of the log. And because of that, we can have x to the base, right? Exponent now move to the base. I mean, exponent now move down. So I don't have to worry about trying to guess exponent anymore, right? So I have x times log by 2. I mean, log by 10 of 2. And the right hand side, what's a log by 10? What's a log by 10? I mean, 10 log base 10 of 10. What is that equal to? So 10 by 2 what to get number 10, right? It's 1. We can know that. So right hand side become 1. Right. So I would say like we use other color here. Logs by 10 of 10 equal to 1. I mean, if you don't believe me, use a calculator, but that's the rule, right? So try that. All right. Okay. And we have now what we're gonna do. Keep in mind that this guy, don't think about, oh, what is the log 2 there? I mean, right? Right now it's just a number actually, right? You can think like that. You can think, well, what does it mean? Is what the power of 10 to get number 2? Yes, but you know, to make it more simple, just think about, oh, it is a number. It is number in there, right? So x multiplied by a number. So in order to solve for x, you can just divide by that number. Do you agree with me? So you're gonna have x equal to 1 divided by log 2. Okay. So then you want to have some number. In this case, you must use the calculator. So 1 divided by, okay, so 1 divided by log of 2. 3.3 something. All right. So I'm gonna write at 3.32. That's good enough to me. 2 decimal place. Yeah. And I'm gonna box answer. Okay. So let's say if someone forgot to get like logs by 10 of 10 equal to 1, right? And you keep that to use calculator, that's still okay. You want to have something like x equal to logs by 10 divided by log by 2, and you will end up with the same answer. Okay, so let me show you. Logs by 10 divided by logs by 2. Okay. And maybe in this case, I should say exponent property. Yep. Okay, so now the next problem, I would like to write the log as a single log. Single log, which means come back. Same meaning is come back. Right? So the first, you can go back you should go back from left to right, but I mean, right now you have to make sure they are having the same base, right? Yes, they are as base 3. So you can look as sum of log and difference of log here. And you see that log maybe of A plus log maybe of C will be log maybe of A and C. So I would like to go ahead and say this gonna be logs by 3 of 5 times 8. There is additional property. Minus 2. And I say using addition, maybe sum of blocks. Right. Let's see to make sure. So I will have loss by 3 here so. And now you can enough simplify by log by 3 of 40 minus log by 3 of 2. And finally, you want to using the difference of logs, right? Because subtraction here, so you have logs by 3. The one have negative in front gonna be the bottom, so that's I have 2 out here, 40 up here, and then you will have logs of 20. I would say is what's that? Different blocks. Make sure the name correctly. Difference. So if you see some things that like a shortcut way, actually I'm gonna think about, can you maybe I'm gonna write a shortcut way here. Make a block here. Shortcut. Okay, so Try to always remember that addition between two logs will be products, the argument, and subtraction will make division. So the one have negative will be in the bottom. The log that have negative in front of it will make the argument become at the bottom. So what I do is I'm gonna make combine logs with the same base, and I have the top will be the and I mean I have the argument of the argument will have a fraction form. Top will be the number that have the top will be the product between all the arguments that have positive in front of log. Have 5 multiplied by 8, and bottom will be the one have negative in front of it. So that's going to be it in a shortcut, and I have logs 3, 20. Keep in mind that I don't have to use calculators to find what is log base 3 of 20 in here gonna be, because I'm trying to have a single log. Okay, so this is the last step I should have. I missed 3 here. Okay, let's do 3.9. Keep in mind that right now I'm having 2 times logs of 5 plus log of 4. Okay, if you have a constant, actually I will not state it out. I'm gonna just tell you in word, speak it out better. So as you see right now, you have 2 you know what, I'm gonna just type for this one. I have 2 times log of 5 plus with logs of 4. Right? And they say evaluate it without a calculator. So by rewriting as a single log. So can I combine this right way? No. Cannot combine yet, because we have constant in front of log 5. Right? How can we make this constant go away? Okay. The only way we can do is try to move this 2, number 2 here, become the exponent of 5. So we apply exponent property for this guy. We have logs by 5 2 plus log 4 Yeah. So simplify it. You have log 25 plus log 4. Okay, now we can combine, right? Because you don't have any issue with, constant in front of it. So I'm gonna move this up. And I say logs product between 25 and 4. And you get log of hundreds. Okay. Here my that. If you don't want to, if you are not allowed to use calculator in this case. You should think that it should be a nice number. So think about logs of hundreds. Actually, it's log base 10 of hundreds, right? So if you convert is to be logs by 10 of 10 raised to 2. Then you can apply the handy rule, handy property that is going to be equal to 2. Or like I say, what is power of 10 to raise to 100? It is 2. All right. Let's move to 3.10. Okay, so when you try to rewrite a log of a combination between product and and a division over there, right? As a sum or different of logs. What you're gonna do is you should start with the fraction form first, right? Because look, generally, it is the fractions as x4 over y, so x4 times y divided by 7. So you should actually start with using the difference blocks. However, as like I say, you can just always think that whatever's whatever term will be at bottom will make the in front of the log will be a negative. So I will just rewrite this as logs x to the power 4 times y minus with the logs of 7. And I can split this to be logs of x to the power 4 plus with log of y. And I will minus the log of 7. And then you see, if you were strong with splitting things, you can actually, right away come to this step if you want, because you can split all the one on the, all the argument on the top as product there change to be addition. And for the one at the bottom there will be a negative. So always make sure that that will be a negative for a term at the bottom, right? So negative log 7. And then you will have to do one more step, maybe. This should be okay to me, Ari, but since this have the power 4 there, you can think about move it to the front of log. So we're gonna have 4 log x plus log y minus log 7. For the second step, I would love to make sure I have the parentheses there. The reason is I don't want you to forget or mess up it to be a log of x power 4, and then the y there is not in the argument, right? So make sure I have parentheses there. Answer must be this one. All right, so that's going to be completely rewrite as some different blocks. So another word they may ask you to do, like expand or extend. The law. Yep. Okay. The next one is 3.11. Let's we go on that. Evaluate the log base 3 of 10 and using change of the base formula. So keep in mind that we want to using the change of base formula. We want to evaluate this guy, right? And by using calculators, you should maybe you're gonna say we should change base to be 10 to evaluate it by calculator. Better. So we have logs by 3 of 10 can be revised as logs base 10. The argument as 10 divided by logs by 10 of 3. Okay. You can also, another way you can do is you change to be natural log, right? You have natural log of 10 divided by natural log of 3, and it should be the same answer. And you will get the answer will be, use the calculator now. Okay, so let's try logs of 10 divided by log of 3. 2.095 something, right? Let's try with natural log of 10. Uh-oh. Divided by natural log of 3. You should have the same answer. Gonna be 2.096. Yeah. So that should be it for 3.11. Okay. Down here is some exercise for us to practice with. I would like to leave it for everyone. Could we give you the answer key for this? Would be 2.465. This one could be two. Answer key is 2. It is you try. And last one is 2.161. Okay. So I will see you guys in the next section. Have a good day.